So the universe technically comes from cold and then it gets hot. So it comes from absolute zero. And all of these mini particles, which are many, become one giant wave, which collapses into one giant particle, which is the singularity, a macroneutron star. And what it's doing is, because it collapses like this and it's made of positrons and electrons, and we know that antimatter explode and produce light and annihilate, or they'll bounce off each other. And because you have this repulsion and attraction, you have a flux, quantum harmonic oscillations. See, technically there's an equal amount of matter and antimatter. Well, there's just a little bit more matter, meaning there was more of a value of an electron versus a positron, which flipped the universe into what it is now, the charge that it has. But because everything basically has an equilibrium, it leans toward a neutronic value, a neutral value. And neutrons decay into protons and electrons. Now, this is why I believe there's one neutron to every 7 protons in the universe. Now, we know that, but this is why. Because H7 has 6 neutrons in it. H6 has 5. H5 has 4. H4 has 3. Tritium has 2. Deuterium has 1. And you have 1 proton and 1 electron in all of these. But this one right here, deuterium, has 1, 1, and 1. So there's an equilibrium here. But at some point, this equilibrium is lost, and then the neutronic value is pretty much gone. Now, it's not that there's not neutrons here, but the ratio is insignificant, which has no neutral value, because it's made of all the particles in the universe, which lost all of this spatial value in between them. And the spatial value reduced and reduced and reduced until they were so close together they were one. And going from this absolute zero to trillions of degrees, once it reaches this nucleonic macroneutron star stage, it'll start losing neutrons, because this is quark-gluon plasma. Essentially, it's just all nucleonic, and it has a lot of color charge. Prior to that, there is no color charge. And the hottest man-made temperature is 9.9 trillion degrees Fahrenheit. So now you only have pretty much a proto value here, protonic value, and an electrophotosphere of negative value or electron value. And when this starts to cool, or basically dies, it spews out positive and negative charges. But for every 7 protons and electrons, there's 1 neutron. And these can collide and form neutrons, but the value is always going to be 1 to 7, because it actually conserves ratios. Here's an analogy. All the particles that became the one giant wave that collapsed into one big particle, many making one, are like the stellar nebula. And the planetary nebula is going to collapse into a macroneutron star, because it's going to start from that, and it's going to go from that -1 to neutral, and then it's going to go to the +1, because that neutron star is going to end up decaying and inflating into protium, which is basically a macro atom, and then it dies. But as that stellar cloud of particles starts to condense, thermal radiation is being emitted, black body radiation, dark light essentially. And you have to understand that this is basically the particles. This is all the particles, because everything that is the universe came from many particles, from one back into what it is now, many and one. And as that cloud condenses, because it comes from the leptons, the lightest, with no color charge, imagine just a gigantic cloud of electrons and positrons. Essentially, it's just leptons, anti-leptons and leptons. And because the electron does not decay, but the muon decays, that means that the electron and the muon neutrino, which emit from a muon, are condensed light that only occurs whenever electrostatic forces gain enough mass and become heavier particles. And now they can emit electron neutrinos and muon neutrinos. And then you're going to get a tau, because the muon is going to become heavier. You're going to get tau. So you can imagine it's like a tau star or a muon star, but it's in this cloud. And these particles do condense and collide and interact and bounce off each other, and there's a lot of activity. But the spatial value itself is decreasing, meaning the whole composite is getting denser and more focused, a focal point. And once it does this, it starts emitting actual light, and it actually has color charge. And this now, everything that all the leptons have gained so much mass that now they're nucleonic, atomic, hadronic. They have color charge. They're part of the nucleus. So there's no nucleus to having nucleus. And this ties to biology, how evolution happened on Earth. So even that shows up. But it takes understanding many fields of science and looking at it in a natural way that it's all connected, that it's not all just this field of science or that field of science or this field of science. You take all those fields, a unified field, boom, you have all the fields of science in one theory. So you can have unified field theory. Now I understand that people say unified field is basically the scalar field. I understand that too. That's my whole point. And what if I told you that Terrence Howard's 1 times 1 equaling 2 actually ties to 0 equals 2? Now you'd say, oh, well, some people probably say, oh, that's crazy. And some people say, well, that makes sense. Now, what is it? Well, I explained it on a couple videos ago. But I'm just going to throw this out here. Like I'm saying, the neutronic value here, the negative, neutral, positive, that decays into a proton and a neutron. Or a proton and an electron, pardon. Because that neutron, or neutral, decay into a positive and electric negative charge. When you combine those, you get a neutron. And when you look up all the values and possibilities of neutrons and how they form and how they decay, and protons and electrons, the relationships, you can see this picture. So yeah, a 0 is a neutral, which equals a positive and negative.